Hello, FullStack Factoids enthusiasts. Welcome back to our channel. Today we have a special treat for you. We are going to build a web service using FastAPI and Python. And guess what? We are doing it in just 10 minutes. Before we dive into the steps, let's take a moment to understand what FastAPI is. FastAPI is a modern, high-performance web framework for building APIs with Python based on standard Python type hints. Some of the key features of FastAPI are fast. It is one of the fastest frameworks for building APIs with Python, only slower than Node.js and Starlet, which is the framework FastAPI is based on. Pythonic. Leveraging Python-type hints, it provides an intuitive way to define your data models, giving you auto-completion and type checking in your favorite IDE. Easy. It is designed to be easy to use and learn. You can set up and start building your robust application in no time. Automatic interactive API documentation. With FastAPI, you automatically get interactive API documentation using Swagger UI and ReDoc that lets you call and test your API directly from the browser. It is a big time saver in the development process. Built-in OAuth 2 and password hashing, security and authentication are built into FastAPI, making it easier to build secure applications with less effort. By using FastAPI, you are not just making your development process faster, but also ensuring that your application is secure and scalable. It's a choice that gives you a fast start and a fast finish. Now that we have a good understanding of what FastAPI is and the advantages it brings to the table, grab your coding gear and let's get started. Step 1. First, let's make sure you have Python 3.6 or higher installed. Next, I'd like to introduce you to the concept of virtual environments in Python. While it's not mandatory, using a virtual environment is a best practice that can save you from a lot of headaches down the road. A virtual environment is a self-contained directory tree that contains a Python installation for a particular version of Python, plus a number of additional packages. To create a virtual environment, navigate to your project's root directory and run this command. Finally, install FastAPI and Uvicorn using the following commands. Now, depending on your system and the way Python is installed, you might have to use Python 3 instead of Python and pip3 instead of pip for the following commands. It's a good practice to be aware of the Python and pip versions you are using to avoid any conflicts. Step 2. Let's create our first endpoint. An endpoint is essentially a specific URL where your API can be accessed. In FastAPI, creating an endpoint is a breeze, thanks to Python decorators. Create a file named main.py. In this file, we will import the FastAPI class and create an instance of it. This instance will be the core of our application, helping us to define and manage our endpoints. Next, we will create a root decorator using app.get. This decorator tells FastAPI that the function below it should be called when the client makes a GET request to the root URL. In the read_root function, we simply return a dictionary with a greeting. When we visit the root URL, FastAPI will automatically convert this dictionary to a JSON response. It's that simple to create an endpoint with FastAPI. Step 3. Running our application will allow us to interact with it through a web browser or tools like Postman. To run the application, we will use Uvicorn, a lightning-fast ASGI server that will host our FastAPI application. Uvicorn not only provides a solid foundation for our app, but also comes with automatic reload capabilities, which means it will automatically pick up the changes we make in our code, saving us from restarting the server manually every time we make a change. In this command, main refers to our main Python file, that is main.py, and app is the FastAPI instance we created in that file. The reload flag enables auto-reloading of the server when we make changes to our code. Once you run this command, Uvicorn will start, and you will see a message indicating that the server is running. You can access your FastAPI application by visiting localhost port 8000 in your web browser. If everything is set up correctly, visiting this URL should show you a JSON response with the greeting we defined in our root endpoint. Step 4. We are now going to dive into one of the powerful features of FastAPI, working with complex, cascading objects. This step is all about setting up structured data models using Pydantic, a data validation and settings management library that integrates seamlessly with FastAPI. We will create 3 Pydantic models: item, order, and transaction. These models will represent different entities in our application, forming a hierarchical relationship where a transaction contains an order, and an order contains a list of items. We are taking our organization to the next level by creating separate files for each of our Pydantic models. This approach not only keeps our project neat and manageable, but also adheres to the best practices of Python programming. Create a models directory where we will house individual files for each model, item, order, and transaction. Each of these files will contain a Pydantic model representing different entities in our application, forming a hierarchical relationship where a transaction contains an order and an order contains a list of items. As you can see, we have defined our models using Pydantic's base model class, and we are utilizing Python's type hints to define the structure of our data. This not only helps in validating the data, but also provides auto-completion and type checking in your favorite IDE, enhancing the development experience. Notice how we are using relative imports to import the necessary models in the order and transaction files. The dot before the module name in the import statement indicates that Python should look for the module in the current directory. With these models in place, we have laid a strong foundation for our API, allowing us to work with nested JSON objects and ensuring data integrity through Pydantic's validation system. Step 5. Now that we have our complex cascading objects set up, it's time to create CRUD endpoints for our FastAPI application. CRUD stands for Create, Read, Update, and Delete, representing the 4 basic functions that we can perform on our data. In this step, we are going to create a simple in-memory storage solution to hold our items. While this isn't suitable for production environments, as data will be lost if the server restarts, it's a great way to quickly get our API up and running for testing purposes. We will create separate routers for each entity, items, orders, and transactions. In each router, we will define endpoints for creating a new entity, retrieving a list of entities, retrieving a single entity by its ID, updating an entity, and deleting an entity. In this snippet, we are defining a router for our items and creating an endpoint to add a new item. We use FastAPI's API router to create a new router, and we define a new route with the router.post decorator, specifying the URL path and the HTTP method. We have also created a Python list named items to hold our item objects. In our create_item endpoint, we accept an item object as a parameter, add it to our list, and then return the item. This approach allows us to create a working API without setting up a database. It's a quick and easy way to start working with FastAPI and to understand how to create and use APIs. However, remember that for a real-world application, you would want to set up a database to store your data persistently. Repeat this process to create routers for orders and transactions, defining the necessary CRUD operations for each entity. Once you have created your routers, don't forget to include them in your main FastAPI application using the include_router method. Step 6. Let's test our endpoints using FastAPI's automatic interactive API documentation. Navigate to localhost port 8000 docs to test your endpoints. Step 7. Let's add error handling to our application. As you can see, we are importing the JSON response class from FastAPI's responses module to craft JSON responses. We then define a custom exception handler for index error exceptions using FastAPI's exception handler decorator. The handler function takes the request and exception details as inputs and returns a JSON response with a 400 status code, indicating a client error and a message informing that the item requested by ID was not found. Step 8. In this segment, we are diving deeper into the middleware enhancements we've integrated into our main file to foster a more secure and transparent FastAPI application. First up is the introduction of a custom logging middleware using the ap.middleware HTTP decorator. This middleware logs every incoming request and the corresponding outgoing response, helping us keep a vigilant eye on the traffic our API is handling. It logs the HTTP method and URL of the incoming request and the status code of the outgoing response, providing a clear trail of all the interactions happening through our API. This is an invaluable tool for debugging and monitoring the health of our application. Next, we have incorporated the core's middleware to manage cross-origin resource sharing, enhancing the security and interoperability of our API. This setup is quite liberal during the development phase, allowing requests from all origins. However, remember to restrict access to specific domains as you move to a production environment to maintain a secure setup. To sum up, these middleware configurations are about building a robust backbone for our FastAPI application, ensuring security while maintaining a transparent operation. And there you have it, FullStack Factoids enthusiasts. We have successfully navigated through the intricate process of setting up a FastAPI project, creating complex cascading objects, and establishing CRUD endpoints, all within a span of 10 minutes. Before we wrap up, a gentle reminder to always test your endpoints through the automatically generated documentation that FastAPI offers. It not only helps in ensuring the robustness of your API, but also serves as a great tool for understanding and documenting your API's capabilities. Looking ahead, keep an eye out for our upcoming episode where we will delve into the world of unit testing, a critical aspect in maintaining the health and efficiency of your application. We will guide you on how to create unit tests for your FastAPI application, ensuring that every component works as intended, providing a seamless user experience. Thank you for joining us in this FastAPI journey. Remember, the road to mastering full-stack development is a continuous learning process, and we are here to guide you every step of the way. Don't forget to like, share, and subscribe to FullStack Factoids for more insightful content. Until next time, happy coding.